Today's LeetCode challenge is about checking whether the binary tree is the mirror of itself. So the link of the problem is in the description. Go and try yourself. It's my recommendation. So let's start. Let's discover what kind of data are provided here. So in general, given the root of binary tree, and we ask it to check whether it's mirror itself, as I mentioned above, there is an integer data type value, which is 0 for now, and left and right, which are none for now. And let's see the structure of the binary tree first. Now let's see first the visualization provided in the LeetCode. As we see, it's root, and these are mirroring left and right roots, and it's the same with others. As we see, the structure we printed here now is the same. Now let's see how the tree is constructed. This is the constructed left tree. We may see the printed version here. This is the constructed right tree. You can see the printed right tree here. Well, now we can print root left value. We say it's 2, which is symmetric to root right value. We may print root right value also. We see it's also 2, which means symmetric. What about root right value? It shows it's 3. You can see here the printed one as well. What about root left value? It is also 3, as we see here, which means root right and root left have the same values. So they are symmetric as well. Then let's check this root left right. It shows 4. What about root right left? It also shows 4. We see both root left right and root right left values are the same, 4. These are symmetric. By the way, the root itself is 1. We have learned how the binary tree is constructed so far. Now we can start our algorithm. We can check nodes recursively. To do this, we need a function. We may call it mirror nodes function. We need a left root and we need a right root, these arguments. Then we recursively check if the left subtree is left matches the right subtree is right. Then we may store it in a variable naming left, right. And also we recursively check if the left subtree is right matches the right subtree is left. We may store it in a variable naming left, right, left. Then we want it return true boolean only if both checks are true. Also, we forgot to set the very vital condition to check if both nodes are present. If both nodes are present, then these subtrees are checked recursively. Okay, after that, we check whether both left root and right root are none. If both nodes are none, it implies that the corresponding nodes in the original binary tree are mirror images of each other. This condition is crucial for the base case in the recursive algorithm. When one of the nodes in a pair is none, it means that the corresponding subtree has reached its end. In a symmetric structure, the other node in the pair should also be none to maintain symmetry. In the next step, we may do the final recursion to traverse the binary tree and compare corresponding nodes to determine if the entire tree is symmetric. In short, we check whether the left and right subtrees of the given root are mirrors of each other. To do this, we need the left subtree of the current root node and the right subtree of the current root node. Let's return and see what will be the result. It's yelling out, showing this error. It says there is attribute error. It's because we didn't handle the base case of the recursion. So let's handle this base case. So we must check whether the root of the current subtree is none or not. If the root is none, it means that the current subtree is empty. And an empty tree is considered symmetric by default. Therefore, the function return is true in this case. Let's see. It worked. Hey world, we solved the problem. Congratulations.